Describe the graph of a quadratic using the leading coefficient and the discriminant. Okay, so first, a reminder, what is a quadratic? Quadratic is a polynomial with degree 2. That means the highest power is 2. And we write the standard form as y equals ax squared plus bx plus c. So the next question is, what does the graph of a quadratic look like? The graph makes a special shape, and it's called a parabola, which is either a U shape opening up like a smile or a U shape upside down like a frown. Let's graph a basic quadratic by plotting points. We'll look at the simple equation y equals x squared, which is a polynomial. The degree is 2. It's a very simple quadratic, and we'll pick some points and try to graph them. If x is negative 2, when you square negative 2, x squared, negative 2 squared would be positive 4. If you square negative 1, you get positive 1. If you square 0, you get 0. If you square 1, you get 1. If you square 2, you get 4. So let's graph those points. The first one, negative 2 in the x, 4 in the y. Negative 1, 1, 0, 0, 1, 1, 2, 4. And when you connect the dots, you get a U-shaped graph, which is called a parabola. So it turns out the leading coefficient tells us something about what the graph is going to look like. If the leading coefficient is a positive number, then the parabola, the graph, will open up. And if the leading coefficient is negative, the parabola opens down. Let's look at these 4 examples and see if we can figure out what the parabola will look like. The first example, the leading coefficient is positive, so the parabola will open up. The second example, the leading coefficient is negative 5, that's a negative number. So the graph of the quadratic will be a parabola opening down. Next example, even though you don't see a number in front of the x squared, there's actually a 1 there. So the leading coefficient is positive, which means the graph opens up. The last example, be careful. It's not written in descending order. The x squared term, the term with the highest power, has a minus 1 in front of it. In that case, the leading coefficient is negative, which means the graph of the parabola will open downward. Now, when we are trying to graph parabolas, there's another thing to consider, and that's the roots. Now, you might sometimes hear people call them solutions or zeros, but when we use those words, roots or solutions or zeros, we're all talking about the same thing, and that is the places on the graph where the graph crosses the x-axis. So let's look at these many examples of different parabolas and see what we see. The first one, we see that this parabola crosses the x-axis in 2 different spots, so there are 2 roots. Here, the next one, the graph crosses in 1 spot, so there is 1 root. The third parabola, if you notice, here's the x-axis. It does not cross the x-axis at all, so there is not any roots. There are no roots. This next example crosses in 1 place, so there's 1 root. And the last example crosses the x-axis in 2 places, so there are 2 roots. Okay, so now we're going to even talk about a new concept which helps us know more about the graph if you're given the equation of a quadratic. Let's first remember the quadratic formula. Remember, we use the quadratic formula as one method to find solutions or roots to a quadratic. Here's the quadratic formula, and it turns out that the part under the square root is very helpful to know how many roots or solutions there will be. This part, b squared minus 4ac, has a special name. It's called the discriminant. Now there are 3 possible cases for the discriminant. Either it's a positive number when you calculate it, or a negative number, or it equals 0. So in the first case, if the discriminant is positive, that means the solutions, x equals minus b plus or minus the square root of a positive number over 2a, it means we're going to actually get two different roots. One root where it's plus the square root of the discriminant, and one root where it's minus the square root of the discriminant. And remember, roots just mean places that the parabola crosses the x-axis. It might look like one of these two graphs, where it crosses the x-axis in two places. Okay, the second scenario is if the discriminant equals 0. You calculate b squared minus 4ac, and you get an answer 0. That means in the quadratic formula, you're going to have minus b plus or minus square root of 0, which is just 0. So you'll have plus or minus 0. It doesn't change anything. What will happen is we'll just get one root, which means the graph of the parabola will only touch the x-axis in one spot. It might look like this graph on the left, where it touches the x-axis in one spot, or this one on the right, where it still touches the axis in just one spot. There's only one root or solution. Okay, the third case is if you do the calculation b squared minus 4ac and you get a negative number. That means you're plugging in the square root of a negative number, which we all know from using our calculator that gives us a math error. It's not a real number, so in this case, we won't get any real roots. So what that means is that the graph of the parabola will not touch the x-axis at all. It might look like one of these two graphs, where it's opening up and floating above the x-axis, or it's opening down and floating below the x-axis. Okay, let's do an example to put together all that we've learned. We have an equation y equals x squared minus 4x, and we want to know, does this graph open upward or downward? So even though it's not written, there's a positive 1 as the leading coefficient in front of x squared, which means the parabola will open up. The discriminant is b squared minus 4ac. Now remember, in the quadratic, right now there's only two terms. The third term would be 0. So your a is 1, your b is minus 4, and your c is 0 in this case. So I'll replace my a, b, and c in the equation. B squared, so that's minus 4 squared, minus 4 times a is 1, times c is 0. The discriminant is 16 in this case, which is a positive number. And we can remember that when the discriminant is positive, that means there are two real roots, which means the parabola will cross the x-axis in two places. Now the next question asks, what are the roots or the zeros of the graph? And just to save time, you can directly use your calculator, your Casio calculator, and press mode 5-3. Then type in A, B, and C, and the calculator will tell us that x1, the first root, is 4, and x2, the second root, is 0. So the parabola will cross the x-axis at the points x equals 0 and x equals 4. So let's graph it. So I know there's roots at 0 and 4, and I know the parabola opens up, so it will look something like this. Let's try one more example. For this one, does the graph open upward or downward? So the first thing we do is look at the leading coefficient, which is a negative number, which means the graph opens downward. We'll find the value of the discriminant, b squared minus 4ac. So we'll replace b is 6, minus 4 times a is minus 1, times c is minus 9. And we end up getting an answer that d, the discriminant, is equal to 0. Remember, when the discriminant's 0, that means the square root term in the quadratic formula is 0, so you're going to have plus or minus 0, which gives us only one solution, or one root. So the graph will only hit the x-axis at one point. We'll quickly use the calculator method, mode 5-3, and we'll type in our a, our b, and our c to figure out what are the roots, or in this case, one root. And after we type all that in, the calculator tells us that the one root is x equals 3. So now we'll sketch the graph. We know that it crosses the x-axis at the point x equals 3, only touches the x-axis at that one spot, and then it opens down. So it should look like this. So that is how you use the leading coefficient and the discriminant to sketch the graph of a parabola.